right, going back to section 3 of chapter 3, we're going to step away from those two-column proofs for a little bit, which I'm sure you are really sad about, but we are going to be looking at proving that lines are parallel or perpendicular, possibly neither, just using some basic algebra that you guys have learned over the years. So in doing so, we need to review how to find the slope of a line, and then we'll use that to identify if they are parallel or even perpendicular. So going ahead and remembering what slope is. Slope is telling you the direction and the steepness of a line. So remember, it's the rise over the run. And you have this wonderful formula of y2 minus y1 divided by x2 minus x1. So formula should look familiar. We've talked about that before. We're going to move on to a couple examples. So just an example of how to find the slope of a line. You have your 2 points. Something that might be helpful to you if you're not sure what to do is go ahead and label this x1 and this is y1. Here's x2 and this is y2. So now you have your slope, which we're going to take y2 minus y1, so 2 minus a negative 2, and divide that by x2 minus x1, so negative 1 minus a negative 3. Subtracting a negative, I'm actually adding, so that's giving me positive 4, and negative 1 minus a negative 3, we're actually adding 3, negative 1 plus 3, so that gives us 2, and 4 divided by 2 is 2, so there's our slope of 2. Just want to do one more real quick. Finding our slope of our line here, so you end up with taking y2 minus y1, so I've got negative 5 minus a negative 5, x2 minus x1, so 9 subtract 6. Up on top here, I end up with 0, divided by 9 minus 6 is 3, and 0 divided by 3 is 0. So when you have a slope of a line, and that slope is positive, this means that my graph would have a line that is increasing from left to right. And here, if I have a slope of 0, what this is doing here is it's telling me I do not have a slope. I have a perfect horizontal line. So just a reminder to you that the slope of a horizontal and vertical line, you have a slope of 0. Meaning there is no rise, there is no run, it is a flat surface. And if you have a vertical line, you have a slope that is undefined. And the reason for this is it's rise over run. Your rise can be anything. You know, here if I look at this, okay, my rise is, we'll go with 9 units, and its run is 0. Well, we cannot divide by 0, therefore your slope is undefined. Now, if these two lines here are horizontal, you might have some horizontal and vertical lines. We need to understand this 0 and undefined to help us here in just a little bit. Now, if lines are parallel versus them being perpendicular, sorry, I got to make the change here. All right, so parallel lines versus perpendicular lines. Parallel lines, two lines, they're never going to cross, so that means that they have to have the same slope. They need to have the same steepness of the line. Now, perpendicular lines, those are going to cross. And in order for them to cross, typically one has to be positive and one has to be negative, and they are going to be opposite reciprocals of each other. You should have learned that in Algebra 1. So if I have a slope of 4, the opposite reciprocal of that is negative 1/4. Reciprocal, you take the fraction and you switch the numerator and denominator. Opposite, meaning you make it positive. If it was negative, make it negative if it was positive. So there's our difference. Just kind of get a little example here of, here's from 4 different slopes. The parallel slope to 2/3 is going to stay 2/3. The perpendicular slope is the opposite, so it's going to be a negative 3/2. I switched the fraction around. Parallel slope to negative 5/7 is negative 5/7. The perpendicular slope to that is going to be a positive 7/5. Parallel slope to 8 is going to be 8, and the perpendicular slope is going to be negative, and then we have negative 1/8 since this is 8/1. The one that always gets people really taken for a loop is when you have a slope of 0. Now the parallel slope to that is going to be 0, and 0 means you have a horizontal line. And if you're going to have a line that's perpendicular to that, it's going to be then vertical, meaning your perpendicular slope would then be undefined. So if you have a slope of 0 and you have a slope that is undefined, that means that these two lines are going to be perpendicular to each other. So where are we going with all of this? Well, we've been proving that lines are parallel to each other using different angle relationships, and now we are going to do this using some arithmetic and proving that lines are parallel just based off of using the slope formula. So if parallel line postulate says that if two lines have the same slope, then two lines are parallel to each other. So I've gone ahead and taken some time here and found the slope going between 2 points. So I have line FG and line HJ, and with this I found the slope. The slope of FG is -5/2, and the slope of HJ is -5/2. Well, these two slopes, they are the same. So that means that FG has to be parallel to HJ because the slopes of the two lines have the same slope of -5/2. Now, this right here is a proof. It may not be a two-column proof, but it's still a proof. You have all of your given information. That's our points. Here, through your work of using the slope formula, it's showing that you know how to use the slope and what you're looking for. Now, that includes all of this work, not just going from the slope and then writing out the answer. How did you get that answer? Rather than writing out in 2 columns, we're showing it in our work. And then there is the explanation. And this one's probably the most important part, and you need to explain why. Why are these two lines parallel to each other? Why are they perpendicular? They are parallel to each other because the slopes of the two lines have the same slope. That's all you need to say. Now, let's say these two lines did not have the same slope. Okay, let's say we had -5/2 and -5/3. Well, we could say that these two lines are not parallel to each other because they do not have the same slope. So that's an example. Then you have the perpendicular line postulate. And there's 2 different ways that you can prove that lines are perpendicular to each other. The postulate says that if the product of two lines is, if the product of, the product of the two slopes of two lines is -1, sorry, then the two lines are perpendicular to each other. So again, I've gone ahead and taken these two lines and already found the slope for us. So I found that the slope of FG is +2 and the slope of HJ is -1/2. Now, hopefully you can clearly see that these two slopes are not the same, therefore they are not parallel to each other, but they are opposite reciprocals of each other. One is +2, the other is -1/2. Now, if I take these two slopes and I multiply them together, 2 times the -1/2 gives me -1. And that's what the perpendicular line postulate says. If the product of the two slopes of two lines is -1, then the two lines are perpendicular to each other. And so when I look at my explanation, you have 2 different ways of doing this. You can use the perpendicular line postulate, like I have here. FG is perpendicular to HJ because the product of the two slopes is -1. Or you could go ahead and say that FG is perpendicular to HJ because the slopes are opposite reciprocals. Uh-oh, hold on. I gotta pause my video here and bring it back. I'm just gonna go ahead and finish this up here. But because the slopes are opposite reciprocals of each other. Now I can't write, my pen's all goofy, but that's another way for you to write out your explanation. So you can either have because the product of the two slopes is -1, or because the slopes are opposite reciprocals of each other. I'm going to pause my video here and bring it right back. All right, so we're back. Now I've got everything working again. We've gone through now, and this is showing you how to determine if two lines are parallel or perpendicular. What I would like you to come to class with tomorrow is you are going to prove whether, there's my dog barking, you're going to prove whether these two lines are parallel or perpendicular or neither. All right, let me stop her for a second. All right, all sorts of interruptions here. So let's say that you have line A, or line AB, so we're going to give you the points of 2 and -3, and B has the points of 4, 9. And what I'd like you to do is determine if the line AB is parallel, perpendicular, or possibly neither to the line of XY, which is going to have the coordinates of -4, 7, and Y, which is going to be at 2, 1. So coming with you to class tomorrow is a proof. So you're going to prove why, or prove to me that these two lines are either parallel, perpendicular, or neither. Not just writing down the word, I want to see the work with it along with the explanation. If you're not quite sure what to do, go back, watch the video again. If you have any questions, make sure you bring those up tomorrow morning.